It is a morning in the summer of 1942 at the Army's Desert Training Center near Indio, California, where the air is already shimmering with heat and the temperature is climbing toward 100 degrees. A young soldier, a recent draftee who, a year earlier, had never operated anything more complicated than his family's farm tractor, climbs down into the driver's compartment of a brand-new light tank. He has been training on the older M5 Stuart, with its temperamental radial aircraft engine, its manual transmission, and its clutch that demanded a delicate touch and a strong left leg. Learning to drive the M5 smoothly had taken him weeks, and he still ground the gears more often than he liked. Now he is being introduced to the new tank, the M5, and his instructor tells him something that he does not quite believe. There is no clutch. There are no gears to shift. You press the accelerator and the tank goes. You let off and it slows. That is all. The soldier settles into the seat, starts the two engines, and presses the accelerator. The tank moves off smoothly, the transmission shifting itself through its ratios without any input from him at all, the whole machine gliding forward with a quiet, even surge of power utterly unlike the clattering, lurching, gear-grinding experience of the M5. He turns, he stops, he accelerates again. Within an hour, he is driving the M5 with a confidence that had taken him weeks to develop in the M5. The tank is quieter, it is smoother, it is cooler inside, and it is, astonishingly, easier to drive than the family tractor he had grown up with. What this soldier does not know as he glides across the California desert in his new tank is why it drives this way. He does not know that the two engines behind him are passenger car engines, built for luxury automobiles. He does not know that the transmissions shifting themselves so smoothly are the same automatic transmissions that wealthy Americans had been buying in their Oldsmobiles and Cadillacs for the previous 2 years. He is driving, without knowing it, a luxury car company's answer to a wartime engine crisis, a light tank powered by 2 Cadillac V8s and 2 of the first automatic transmissions ever mass-produced. He is driving a Cadillac that happens to be a tank. The story of the M5 Stuart begins, like so many American tank engine stories, with the radial engine problem. The standard American light tank of 1941 and early 1942 was the M5 Stuart, a compact, fast, reliable little tank that had proven effective in the early desert fighting in North Africa and was being supplied in large numbers to the British under Lend-Lease. The M5 was a good tank for its class, but it was powered by an air-cooled radial aircraft engine, the Continental W670. A 7-cylinder radial that had originally been designed for airplanes, and the radial engine was a problem for the light tank just as it was for the medium Sherman. The problems were familiar. The radial engine ran on high-octane aviation gasoline, which complicated the fuel supply and which the engine shared with the aircraft that desperately needed it. The engine was tall, which forced the tank's hull to be tall, making it a bigger target and harder to armor effectively. It was noisy, it was complex to maintain in the field, and, most critically, it was in short supply because the aircraft industry needed every radial engine it could get, and the demand for these engines was outstripping the production capacity. Every Continental radial that went into a light tank was an engine that the growing American Air Forces wanted for training aircraft and other uses. The light tank program, like the medium tank program, was being strangled by the competition for radial aircraft engines. The Army needed an alternative engine for its light tanks, an engine that did not compete with the aircraft industry, that ran on ordinary gasoline, that was shorter and quieter and easier to maintain, and that could be produced in large numbers without straining the aircraft engine supply. And once again, the Army turned to the automobile industry, but this time, the answer would come from the most unlikely division of all, the maker of America's most prestigious luxury cars. This is the paradox at the center of the story. The engine crisis that threatened American light tank production was solved by Cadillac, the General Motors division whose entire identity was built around luxury, refinement, and prestige, the maker of the cars that wealthy Americans bought to signal their success. Cadillac was the opposite of a military supplier. It built smooth, quiet, expensive automobiles for the carriage trade. And yet it was exactly Cadillac's commitment to smoothness, quietness, and refinement that made it the perfect company to solve the light tank engine problem. The very qualities that made a Cadillac a luxury car, the smooth V8 engine, the self-shifting automatic transmission, turned out to be exactly the qualities that made a better tank. The resolution of the paradox is that the engineering of luxury and the engineering of military effectiveness are not as different as they might seem. A luxury car engine is smooth, quiet, reliable, and easy to operate because those are the qualities that luxury buyers pay for. A tank engine needs to be reliable, and it turns out benefits enormously from being easy to operate because tank crews are trained quickly in wartime, and a tank that is easy to drive is a tank that can be operated effectively by an inexperienced crew. The automatic transmission, developed by Cadillac and Oldsmobile to spare wealthy drivers the bother of shifting gears, turned out to be a military asset because it let a farm boy learn to drive a tank in an hour instead of weeks. Cadillac's luxury engineering, applied to a tank, produced a tank that was smoother, quieter, cooler, roomier, and dramatically easier to operate than its predecessor. The luxury car company did not have to abandon its values to build a tank. It had to apply them. And the result was one of the most successful light tanks of the war. The popular history of American tanks in the Second World War is dominated by the Sherman, the medium tank that did most of the fighting and took most of the losses. The light tanks, the Stuarts, get relatively little attention, and the specific story of the M5, with its twin Cadillac engines and its automatic transmissions, gets almost none. This is a shame because the M5 represents one of the most interesting and forward-looking pieces of engineering in the entire American tank program. It was the first tank in history to use automatic transmissions, an automotive first that anticipated, by decades, the direction that both military and civilian vehicle design would eventually take. And it was a beautiful example of how the American automobile industry could adapt its existing civilian products to military purposes with extraordinary speed and effectiveness. The men and the company behind the M5 deserve more recognition than they have received. Cadillac, an American luxury car maker, took its passenger car V8 engine and its pioneering Hydra-Matic automatic transmission, both developed for the civilian luxury market, and combined them into a tank powertrain in a matter of months. The result was a tank that crews loved, that the British nicknamed the Honey for its smooth ride, that simplified training, that ran on ordinary gasoline, and that served in every theater of the war. The twin Cadillac powertrain was an inspired piece of improvisation, taking proven civilian components and combining them into a military powertrain that was, in important respects, more advanced than anything in any other tank in the world. The story of how a luxury car company gave the American light tank two V8s and automatic transmissions is a story worth telling, and it has been largely forgotten. To understand the M5, you have to understand Cadillac and what kind of company it was. Cadillac was the prestige division of General Motors, the maker of America's premier luxury automobiles. The Cadillac name was synonymous with quality and refinement, so much so that the phrase "the Cadillac of" applied to any product meant the best of its kind. Cadillac's engineering culture was built around the pursuit of smoothness, quietness, and reliability, the qualities that defined a luxury automobile. Cadillac engineers spent their careers learning how to make engines run more smoothly, how to eliminate vibration and noise, how to make a car effortless and pleasant to drive. This was a very particular kind of engineering expertise, focused not on raw performance or on cost, but on refinement. The centerpiece of Cadillac's engineering by the early 1940s was its V8 engine. Cadillac had been a pioneer of the V8 engine in American automobiles, and by 1941, its V8 was a refined, smooth, reliable power plant, a 346 cubic inch L-head monoblock design that produced about 150 horsepower in its passenger car tune. It was the engine that powered Cadillac's luxury cars, smooth and quiet and dependable. And alongside the engine, Cadillac and its sister division Oldsmobile had developed something even more remarkable, a transmission that shifted itself, the Hydra-Matic, the first mass-produced fully automatic transmission in the history of the automobile. These two products, the smooth V8 and the self-shifting automatic transmission, were the crown jewels of Cadillac's civilian engineering. And when the war came and the Army needed a light tank engine, these civilian crown jewels would become the heart of a tank. The Hydra-Matic transmission deserves its own explanation because it was a genuine revolution, and its application to a tank was one of the most forward-looking engineering decisions of the war. For the entire history of the automobile up to that point, drivers had to shift gears manually, operating a clutch with one foot and moving a gear lever by hand, coordinating the two in a learned skill that took practice to master and that many drivers never fully mastered. Shifting gears smoothly without grinding or lurching was an art. The Hydra-Matic transmission eliminated it entirely. Introduced by General Motors in 1940, first in Oldsmobiles and then in Cadillacs, the Hydra-Matic was the first commercially successful, fully automatic transmission. It used a fluid coupling and a system of planetary gears with hydraulic controls to select the appropriate gear ratio automatically, based on the vehicle's speed and the driver's use of the accelerator. The driver simply pressed the accelerator, and the transmission did the rest, shifting itself smoothly through its 4 speeds without any clutch and without any gear lever. The Hydra-Matic was a sensation in the civilian market. It made driving dramatically easier, eliminating the most difficult skill that driving required. Wealthy buyers loved it, and it became a prized feature of the luxury cars that offered it. It was, in 1940 and 1941, the most advanced automotive transmission technology in the world, and it was uniquely American, a product of General Motors engineering that no other automaker had matched. And it was this transmission, developed to spare luxury car buyers the effort of shifting gears, that Cadillac would put into a tank. The implications were profound. A tank with an automatic transmission would be far easier to drive than a tank with a manual transmission. The driver would not have to master the difficult art of shifting a heavy military gearbox while bouncing across rough terrain under fire. He would simply press the accelerator. For an army that had to train tank drivers quickly, by the tens of thousands, the automatic transmission was not just a convenience. It was a force multiplier, a way to turn inexperienced draftees into competent tank drivers in a fraction of the usual time. The idea for the M5 powertrain emerged in the spring of 1941 as the radial engine shortage was becoming acute. Cadillac, looking at the problem, recognized that it had the components to solve it. The Cadillac V8 was a smooth, reliable, proven engine running on ordinary gasoline, already in mass production. The Hydra-Matic transmission was a proven, mass-produced automatic. The challenge was that a single Cadillac V8, producing about 110 horsepower in a detuned military configuration, was not powerful enough on its own to move a tank that weighed around 15 tons. The M3's radial engine produced around 250 horsepower. A single car engine could not match that. The solution was the same solution that General Motors had used for the Sherman's diesel, and that Chrysler had used for its multibank, the solution of combining multiple engines. Cadillac proposed to use 2 of its V8 engines, mounted side by side in the rear of the tank, each one coupled to its own Hydra-Matic automatic transmission, with the outputs of the 2 transmissions combined through a transfer case that drove the tank's tracks. 2 engines, each producing about 110 horsepower, would together produce about 220 horsepower, enough to move the light tank with good performance. Each engine had its own transmission, its own cooling system, its own carburetor and accessories, functioning as a complete independent power plant, with the two units combined only at the transfer case. In June of 1941, the Ordnance Committee authorized the installation of two Cadillac engines with Hydra-Matic transmissions and an auxiliary transfer case in a modified Stuart light tank. The twin Cadillac tank was born. The engineering of the twin Cadillac powertrain was elegant in its use of proven components. The two Cadillac V8 engines were mounted side by side in the rear of the tank, with their cooling fans facing toward the rear. Each engine was a 346 cubic inch L-head V8, basically the same engine found in the 1941 and 1942 Cadillac passenger cars, modified for military use with a 12-volt electrical system and detuned to about 110 horsepower net for reliability and durability. Each engine was bolted to its own 4-speed Hydra-Matic automatic transmission in the usual fashion, exactly as the engine and transmission were mated in a Cadillac automobile. Each transmission drove a short propeller shaft, and the two propeller shafts fed into a common transfer case which combined the power of the two engine transmission units and delivered it to the tank's final drive and tracks. The radiators were mounted horizontally above the engines, and each engine drew its intake air through a long pipe from a large air cleaner at each rear corner of the tank, an arrangement designed to cope with the dust of off-road operation. The control of the two engines was cleverly synchronized. The throttle linkages for the two engines were connected by a horizontal cross shaft, operated through a series of mechanical relays from the accelerator pedal at the front of the tank. The driver pressed a single accelerator pedal, and both engines responded together, their throttles opening in unison. From the driver's point of view, the twin-engine, twin-transmission powertrain behaved like a single integrated power plant. He pressed the accelerator and both engines surged, both transmissions shifted themselves, and the tank moved smoothly forward. He did not have to manage two engines or two transmissions. He simply drove, and the complex machinery behind him handled the coordination automatically. The system worked, and it worked smoothly, giving the M5 a refinement of operation that no other tank in the world could match. It was, in effect, a tank that drove like a Cadillac because it was, mechanically, two Cadillacs. The new powertrain required a redesigned tank, and the redesign produced a better tank in several ways. The twin Cadillac engines, being shorter than the tall radial, allowed the rear of the hull to be reshaped, and the overall design was modernized with lessons learned from the M3A3 variant of the Stuart. The new tank, initially designated the M4, but quickly renamed the M5 to avoid confusion with the M4 Sherman medium tank, featured an all-welded hull from the outset, eliminating the riveted construction of the early Stuarts. This was an important improvement because riveted armor had a dangerous flaw. When a riveted hull was struck by enemy fire, the rivets could shear off and fly around the inside of the tank as deadly secondary projectiles, wounding the crew even when the armor itself was not penetrated. The welded hull of the M5 eliminated this danger. The new hull also featured a sloped glacis plate at the front, improving the armor protection, and the driver's hatches were moved to the top of the hull. The reshaped rear hull, accommodating the twin engines, gave the M5 a much roomier interior than the M3, improving crew comfort and ergonomics. The tank was quieter because the Cadillac V8 engines were far quieter than the radial. It was cooler inside because the engine and cooling arrangement managed heat better. And it was, above all, easier to drive because of the automatic transmissions. The M5 retained the same 37mm main gun as the M3, which was its principal weakness because the 37mm gun was increasingly inadequate against German armor. But in every other respect, the M5 was an improvement on the M3, a more modern, more comfortable, more refined, and easier to operate tank. The improved M5A1 version, introduced later in 1942, added an enlarged turret derived from the M3A3, with a rear bustle for radio equipment, a gyro-stabilized gun, and various other improvements. The M5A1 became the definitive version of the Stuart, and the great majority of M5 series production was of the M5A1. The twin Cadillac M5 went into production with impressive speed. Production began at the Cadillac Division's Detroit plant on April 30, 1942. Within months, production had been expanded to additional facilities. A General Motors plant at Southgate, California, began building M5s in August of 1942, and the Massey Harris Company, an agricultural equipment manufacturer, began building them in July of 1942. The initial M5 was succeeded by the improved M5A1, which was standardized in September of 1942 and entered production in November, eventually replacing the M5 at all the plants and being joined by the American Car and Foundry Company as a fourth producer in October of 1943. Total production of the M5 and M5A1 came to 8,884 tanks between 1942 and 1944, with the M5A1 accounting for about three-quarters of the total. An additional 1,878 M8 howitzer motor carriages, a self-propelled gun based on the M5 chassis, were also produced. The fact that an agricultural equipment company like Massey Harris could build the M5 illustrates one of the great strengths of the American approach. The tank was built largely from proven, mass-produced automotive components, the Cadillac engines and the Hydra-Matic transmissions, assembled into a vehicle whose construction had been simplified and rationalized. This meant that the tank could be built not only by Cadillac, but by other manufacturers with general mechanical and manufacturing capability, spreading the production across multiple companies and multiplying the output. The use of standardized civilian-derived components was a recurring theme of American war production, and the M5 was a particularly clean example. A luxury car engine, a civilian automatic transmission, and a simplified welded hull combined into a tank that could be built by car companies and farm equipment companies alike by the thousands. The soldiers who operated the M5 generally liked it, and the reasons reflected exactly the qualities that Cadillac had built into it. The most immediate advantage was the ease of operation. The automatic transmissions meant that there was no clutch to manage and no gears to shift, which dramatically simplified the task of driving the tank and dramatically reduced the time required to train a driver. A new crew member could learn to drive the M5 competently in a fraction of the time it took to learn the M3 with its manual transmission. In a wartime army that had to train tank crews quickly by the tens of thousands, this was an enormous practical advantage. The automatic transmission turned tank driving from a difficult skill into an easy one, and it did so at exactly the moment when the Army most needed to train large numbers of inexperienced men quickly. Beyond the ease of driving, the crews appreciated the refinement of the M5. It was quieter than the M3, which mattered both for crew comfort and for tactical concealment, since a quieter tank was harder for the enemy to hear approaching. It was cooler inside, which mattered enormously in the deserts and the tropics where the Stuart often fought. It was roomier, giving the crew more space to do their jobs, and it was smooth, with the twin V8 engines and automatic transmissions delivering power evenly and pleasantly, without the lurching and clattering of a manual transmission tank. The British, who operated the Stuart extensively, had nicknamed the M3 the Honey for its smooth and pleasant ride, and the M5, with its automatic transmissions, was smoother still. The tank that a luxury car company had built drove like a luxury car, and the crews who depended on it appreciated every bit of the refinement that Cadillac had engineered into it. It would be dishonest to present the M5 as a perfect tank, because it had a serious and fundamental weakness that no amount of powertrain refinement could overcome. That weakness was firepower. The M5 retained the 37mm main gun of the M3, and the 37mm gun, adequate against the light tanks and infantry of the early war, was increasingly inadequate against the German armor of the middle and late war. Against a German Panzer IV or a Panther, the M5's 37mm gun was nearly useless, unable to penetrate the frontal armor at any reasonable range. The M5 was a light tank, and it had the firepower of a light tank, which by 1943 and 1944 was simply not enough to fight enemy tanks. This firepower problem was not unique to the M5, and it was not really the fault of the M5's designers. It was a consequence of the fundamental nature of the light tank, which traded firepower and armor for speed and mobility. The lesson of the war, learned the hard way in North Africa and elsewhere, was that light tanks could not survive in direct combat against enemy medium and heavy tanks. The role of the light tank had to change. Rather than fighting enemy tanks, the light tank was relegated to the roles for which its speed and mobility suited it: reconnaissance, scouting, screening, flanking, and infantry support. In these roles, the M5's weak firepower mattered less, because it was not expected to fight enemy tanks head-on, and its speed, mobility, reliability, and ease of operation became its principal virtues. The M5 was used as the eyes of the armored force, racing ahead to scout the enemy, screening the flanks of the advance, and supporting the infantry against soft targets. In these roles, it served well, and its weak gun was an acceptable limitation. But the firepower problem meant that the M5, for all its refinement, was never a frontline tank fighter, and the light tank concept itself was approaching the end of its usefulness. The M5 Stuart served in nearly every theater of the Second World War. Its first combat use came in the North African campaign, with the American landings in Operation Torch in November of 1942. In North Africa and later in Italy, the M5 was used for reconnaissance and for the cavalry and scouting roles to which its speed and reliability suited it. In the European campaign after D-Day, the M5 served in the reconnaissance and screening roles, racing ahead of the main armored forces to locate the enemy, screening the flanks, and supporting the infantry. Its speed and agility made it valuable for these roles, even as its weak gun kept it out of direct tank combat. In the Pacific, the M5 found a more combat-oriented role, because the Japanese tanks it faced were themselves light and lightly armored, and the M5's 37mm gun was adequate against them. In the island fighting, the M5 supported the infantry and engaged Japanese armor and fortifications, and its reliability and ease of operation served it well in the harsh tropical conditions. The M5 was also supplied to the Allies through Lend-Lease, continuing the pattern established with the M3 Stuart. The British operated the M5, which they designated the Stuart Sixth, alongside their other Stuart variants, using them primarily for reconnaissance, after the lessons of North Africa had shown that light tanks could not survive in direct combat against German armor. The Free French and other Allied forces also operated the M5. The tank that Cadillac had built served on every front in the hands of many nations, performing the reconnaissance and support roles that the light tank had come to fill. It was never a glamorous tank, never a tank that won famous tank battles, but it was a reliable, fast, easy-to-operate workhorse that did the unglamorous but essential work of scouting and screening and supporting, and it did that work well. The M5 was the last of the Stuart line, and its replacement reflected the lessons that the war had taught about light tanks. By 1944, it was clear that the M5, with its 37mm gun and its relatively thin armor, was approaching obsolescence. The Army developed a successor, the M24 Chaffee, a new light tank that addressed the M5's principal weakness by mounting a 75mm gun, giving the light tank real firepower for the first time. Interestingly, the M24 chassis retained and refined the twin Cadillac powertrain concept that the M5 had pioneered, using twin Cadillac engines and Hydra-Matic transmissions in a more developed form. The powertrain that Cadillac had created for the M5 was good enough that it carried forward into the next generation of American light tank, validating the original design decision. The M5 was succeeded by the M24 in 1944, and production of the M5 ended that year. But the twin Cadillac automatic transmission powertrain concept did not end. It had proven itself, and it influenced post-war armored vehicle design. The demonstration that mass-produced civilian-derived automotive components, the Cadillac V8 and the Hydra-Matic transmission, could function effectively in demanding military service was an important lesson, one that shaped how military vehicles would be designed and powered in the decades that followed. The automatic transmission, in particular, which the M5 had introduced to armored warfare, became increasingly standard in military vehicles as the advantages it offered, ease of operation, reduced training time, smooth power delivery, became universally recognized. The M5's powertrain was ahead of its time, and the direction it pointed toward automatic transmissions and automotive-derived components in military vehicles was the direction that the future took. The lesson of the M5 Stuart is a lesson about the unexpected military value of civilian refinement. Cadillac was a luxury car company, and its engineering culture was devoted to qualities, smoothness, quietness, ease of operation that seem, at first glance, to have nothing to do with military effectiveness. War, one might think, is about toughness and firepower and armor, not about smoothness and ease of operation. But the M5 demonstrated that the qualities of luxury engineering had real military value. The smooth, quiet, reliable Cadillac V8 made a better tank engine than the noisy, complex radial. The automatic transmission, developed to pamper luxury car buyers, turned out to be a genuine military asset because it made the tank dramatically easier to operate and dramatically faster to train crews on. The refinement that Cadillac built into its luxury cars translated almost directly into military effectiveness when applied to a tank. This is a lesson that runs counter to the intuition that military equipment should be crude, tough, and simple. Sometimes the qualities that matter most in a weapon are the qualities of good engineering in general: reliability, ease of operation, smoothness of function, qualities that a luxury car company devoted to refinement is particularly well equipped to provide. The M5 was easy to drive, and ease of driving meant that inexperienced crews could operate it effectively, which meant that the tank could be fielded in large numbers with quickly trained crews. The M5 was reliable, and reliability meant that the tank kept running, which is the most important quality any military vehicle can have. The M5 was refined, and the refinement, far from being a frivolous luxury, was a real military advantage. Cadillac did not have to become a different kind of company to build a good tank. It had to apply the engineering values it already had. And those values, the values of luxury, turned out to make a surprisingly good tank. The single most forward-looking aspect of the M5 was its use of the automatic transmission, and this deserves emphasis because it was genuinely ahead of its time. In 1942, the automatic transmission was a brand new technology, available only in a handful of luxury American automobiles, unknown in the rest of the world. No other country's tanks used automatic transmissions. German tanks, British tanks, Soviet tanks all used manual transmissions with clutches and gear levers that demanded skilled operation. The American decision to put automatic transmissions in the M5 was a bold application of cutting-edge civilian technology to a military vehicle, and it gave the M5 a real advantage in ease of operation and crew training that no other tank in the world possessed. The advantage was particularly significant in the context of mass mobilization. The American Army had to train enormous numbers of tank crews, drawn largely from civilians who had never operated military vehicles. Many of these men had limited experience even with automobiles, and learning to drive a manual transmission tank with its heavy clutch and its difficult gearbox was a real challenge that took significant training time. The automatic transmission eliminated most of that challenge. A man who could barely drive a car could learn to drive an M5 quickly because the automatic transmission did the hard part for him. This force-multiplying effect, the ability to turn inexperienced men into competent tank drivers quickly, was a real military advantage in a war of mass mobilization. The automatic transmission was not just a convenience. It was a way to make the most of the human material that the Army had to work with, to field effective tank crews faster than would otherwise have been possible. And it pointed the way to the future, when automatic transmissions would become standard in military vehicles around the world, an innovation that the M5 Stuart had pioneered in 1942. There is a poignant quality to the story of Cadillac going to war, of the maker of America's most luxurious automobiles turning its engineering to the production of tanks. The same Cadillac division that, in peacetime, built the elegant cars that symbolized American success and prosperity spent the war years building light tanks for the Army, applying its expertise in smooth V8 engines and automatic transmissions to the harsh demands of armored warfare. The Cadillac craftsmen who had built luxury cars built tanks instead. The Cadillac engineers, who had pursued refinement for its own sake, found that refinement had a military purpose. And the Cadillac V8 engine, the heart of America's most prestigious automobile, found itself by the thousand in the rear hulls of light tanks, fighting in the deserts of North Africa, the mountains of Italy, the hedgerows of Normandy, and the jungles of the Pacific. After the war, Cadillac returned to building luxury automobiles, and the M5 Stuart became a footnote in the company's history, overshadowed by the glamorous cars that defined the Cadillac brand. But for a few years, Cadillac had been a tank manufacturer, and a good one, building nearly 9,000 light tanks that served on every front of the war. The twin Cadillac powertrain, the smooth V8 engines, and the pioneering automatic transmissions had given the American light tank a refinement and an ease of operation that no other tank in the world possessed. It was an unlikely contribution from an unlikely source, the luxury car company that gave the Army a tank that drove like a Cadillac. And the soldiers who drove it, the farm boys who learned to operate it in an hour because there was no clutch and no gears to shift, never knew that they were driving the product of America's finest luxury car engineering, applied for a few strange and desperate years to the business of war. In a war decided by what could be operated was a tank that drove like a Cadillac because it was two Cadillacs. The luxury car company took its smooth V8 engine and its pioneering automatic transmission, the crown jewels of its civilian engineering, the products it had developed to pamper wealthy buyers, and it combined them into a tank powertrain. Two engines, side by side, each with its own self-shifting transmission, combined through a transfer case controlled by a single accelerator pedal. The driver pressed the pedal and the tank surged forward, both engines responding together, both transmissions shifting themselves, the whole machine gliding ahead with a smoothness and a quietness that no other tank in the world could match. The farm boy, who had never driven anything more complicated than a tractor, learned to drive it in an hour because there was no clutch and there were no gears, and the hardest part of driving a tank had been engineered away by a company devoted to making driving effortless. The radial engine that had powered the old light tank was noisy, hungry for aviation fuel, in short supply, and hard on its crews. The twin Cadillac engines were quiet, ran on ordinary gasoline, freed up the radials for the aircraft that needed them, and made the tank smoother and cooler and roomier and easier to drive. The automatic transmission, ahead of its time by decades, ahead of every other tank in the world, turned tank driving from a difficult skill into an easy one, and in a war of mass mobilization, where inexperienced men had to be turned into competent tank crews quickly, that ease was a real military advantage, a force multiplier disguised as a luxury feature. Cadillac did not abandon its values to build a tank. It applied them, and its values, the values of refinement, turned out to make a surprisingly effective weapon. In a war fought between industries, the industry that could turn a luxury car maker into a tank manufacturer, that could put a passenger car V8 and a civilian automatic transmission into a light tank and have it serve on every front of the war, was an industry whose depth and flexibility its enemies could not match. The M5 was never a great tank fighter. Its 37mm gun was too weak, and the light tank concept was approaching the end of its usefulness. But the M5 was a superb reconnaissance and support vehicle, fast, reliable, refined, and so easy to operate that a draftee could master it in an hour. It served everywhere. It was loved by its crews, and its twin Cadillac powertrain, with its pioneering automatic transmissions, pointed the way to the future of military vehicle design. The luxury car company gave the Army 2 V8s and automatics, and the Army got a tank that drove like a dream. In a war decided by what worked, the Cadillac worked smoothly and quietly and reliably on every front of the war. That was enough. It was, in the end, one of the unlikeliest and most refined contributions that American industry made to victory, a tank built by the company whose name meant the best of everything, applying the engineering of luxury to the business of war.